Million to power millennium. Good morning, namaskar. This is Engineer Suraj Singh speaking for Bharat India on this day, April 23rd, 2022, Saturday 3:23 AM. मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ। आज दिनांक 23 अप्रैल 2022 शनिवार सुबह के 3:23। Topic of talk is same as it was before, and that is real quality requirement, coordination engineering, only way, projects, works, designs, contracts, reliable engineers, power of communication, concrete specifications, civil engineering, safety, health, environment, methods, disputed claims, and what we do. This is talk. Long back we started this talk with a view, with an objective that people should be educated and awareness be raised among people, among engineers as well, to think of quality, to think of coordination. This is my email ID, suraj_engineer engineer at yahoo.co.uk, and that's my certification. Chartered Engineer India, because I am fellow of Institution of Engineers India. Fellow and member and associate member are automatically authorized to use Chartered Engineer India. Additionally, I am approved as an international professional say this is an arbitration engineer certificate issued by Institution of Engineers India. This is for purpose of arbitration, and I have been placed on panel of arbitrators of Institution of Engineers India according to law. And of course, this is my Chartered Engineer certificate, Chartered Engineer India, that is based on qualification, professional training, and corporate membership. Civil engineering division I belong to, and this is Chartered Engineer India. And this is my quality file, this is my coordination file. I close C file and I close arbitration file, so that I talk on quality issue, and I'll open concrete file also. I speak on behalf of my country and whole world. This is regarding real quality and real coordination, which are very significant currently for everyone. I experience really unpleasantly, you might be doing same. Why say quality, state of quality in every walk of life has to be considered. We spend money on products, on materials and whatever, and if we don't get quality as expected, this means consumer is defeated. Without quality, consumer has to buy a product and suffer because of absence of intended quality, required quality within that product. And that's problem here. That constitutes problem. Every product I'm talking, in every branch of engineering or otherwise, if I don't get that product or service, it's really annoying, because after all, nothing is purchase free. Every item that we purchase is paid, and we have no standards here. There are so many standards from Indian codes, Indian standards. There are so many standards in every country, but just having standards in books doesn't mean anything. Real quality is a requirement. It's not simply quality I'm saying. Real quality means quality that we achieve or we get or we are delivered. Same way quality can be delivered. Quality is dependent on information provided or whatever support has been given by coordination to whosoever is involved in quality, and that person has to use that information. And if that individual person or professional is not competent enough to even to understand what information is required, in that case that person cannot be called a professional. That person cannot be called a professional and should not be given that level of responsibility unless that person gets competency in that respect. There's no meaning of saying we are aware of quality, we are aware of quality system if we can't deliver quality. Delivery is important, just like work done is important. We may say we have good design, but that design is not implemented, means quality is not done. Quality is actually that requirement without which work cannot be of time, wastage of energy, and wastage of thing. Everything is related to money. After all, nothing is free. So we have to be realistic about this issue, how to deal with that, and we have to deal with quality along with quality system. We cannot simply say that we keep quality requirement or deliver quality in isolation of system and quality product or product quality both must move together. We have to rethink, we have to redecide, we have to consider value and quality of product rather than exclusively system quality. Quality system is audited, it is done, it doesn't prove anything. To be very frank, it may be whatever ISO 9000 or Sigma or what. If you can't deliver a product, that means there is a fake system or worse persons involved are fake. I don't blame particular person, but that point cannot be ignored. Person is fake. Why that person is fake? Because that person is least bothered. Everybody wants its own way, but what is required is we have to do work, we have to do whatever work. It should be done according to whatever is demanded or whatever is instructed in forms of specifications or designs. And if we can't do that, this means we are not professional or we don't care. When we say professional, it's very important word. Meaning of professional, but what I understand is profession means it's a kind of work religion. I consider profession as work religion. I'm not saying worship religion, work religion or worship religion. It should be treated as that level, that it is logical, it is based on facts, it is based on trust, it's based on commitment. Means we should have many points, many criteria to that extent. When we do some work, we should be sure of that, and we should do only after knowing everything about that. If you say, no, I've done it and I have done it means it's right, no, that's not way. Okay, you are a professional, you must have collected all informations and put together in that so that all informations are linked together, or you can say it is well coordinated. And then the work is done. Maybe first go it shall take more time, but when you get a habit of that, you completely or you can extract all information and then do job. I think that is what is required. Information is required. Which information is required? Professional knows it. If professional does not know it, that person is not professional or not qualified. Experience is a qualification in itself. In fact, you say, if you have real experience, you are having higher qualification than ordinary degree. Or you can say experience is better degree than academics. Of course, academics is primary and it is very important to have, but application of knowledge that you earn through your academics must be observed, must be experienced by implementing that, executing that one. And by execution or through execution and during execution, we learn a lot about properties of that material, conduct of that material, how that material conducts, how it behaves with other materials, and how do work people, work persons take that into their spirit. And that's what we say. Learning comes from there. Real learning comes from working, from service, or from whatever plant or construction that we have to understand thoroughly. It's not simply because I am saying you accept this. No, don't accept this. Work yourself, experience yourself. You see, when there is, you can say, breakdown of fire, there is a break of fire, you have to extinguish fire, or fire will spread continuously. It will not see any haze. Job of fire is that same way. Coordination is a cooling, means you have to cool everything down. You have to understand everything down. Coordination is something that's very constructive. It's not demolishing, it's not destructive. Coordination means whatever is expected, we have to collect together, understand that, analyze that, and link that. Maybe it's not in sequence, we have to keep them in sequence. And only then we can say, well, we have done every coordination, there's nothing left. To an extent, this work is concerned. Maybe there are more requirements, but do not apply to that work. That's what we have to see. All information put together and then well understood. And you may say it's in kind of graphics, or it's kind of writing, or it's, it is to be explained to those who work online. In field, if they work well, once it may take more time, second time, third time, fourth time, and when you go further and further, that person shall repeat it again and again and get expertise of that after a while. That's what I'm saying. Coordination is that level important. We engineers have to handle these domains. If we don't handle these domains, then engineer has got no meaning. Engineer is a layman in that case. Engineer is illiterate in that case. Engineer can't be called serious in that case. If engineer ignores or overlooks that, and it's job of engineer or whosoever is responsible for either production or for manufacturing or for construction or for whatever work one does, it's duty of that person to be clear about what work is to be done. We cannot just keep learning or trying. We do work. We have to accumulate first in our minds what way we have to do. What is best way, and if we can write, it's better, because it's easy to explain to everyone. And everyone who is involved in the lowest category of person should know what that duty is. From top to bottom, in whatever field, it may be construction, it may be factory work. Construction is more important because everybody has its own role. And roles are based on experience, and it's not well defined. And if you define them well, I think that's best policy. Everyone, it may be in safety department, safety section, or quality section, or construction section, or planning section, or whatever section, they have to understand respective roles. How can you say that it's going on well? You cannot say that. So I say we have to establish both domains in practice. I know there is no separate branch of engineering about, you may say, quality or coordination. Those are subsets of the disciplines only, quality discipline. But quality discipline has to understand what is requirement. It's not simply a system. We say, okay, we have a system in place and we follow this system. That's not adequate. That's not enough. System is to be designed properly, and system has to take into its consideration all factors that can claim that product is guaranteed. And if product is not guaranteed, there exists no meaning of system, and system is floppy one. We have to be very careful about this. If system is floppy or sloppy, there exists no meaning of quality, and to make it perfect or to make it deliverable from engineering point of view, from manufacturing point of view, from construction point of view, from design point of view, we have to keep in mind that every requirement is a must. Every requirement is a must. We cannot simply say we have gone through this system, this procedure, which means work should be done accordingly, perfectly, professionally. No, we don't accept. This was assumed before. Now, it is material, it must be valued, because ultimately it's product that is used, it's not method or it's not system. It's product that is to be used wherever you want to use. It may be used in spare parts are original parts, it may be used in concrete, it may be used in wherever. And that's really very to establish both. If we can establish both quality engineering and coordination engineering, I think that's the best way, that every engineer should be a quality related person, and every coordination engineer is interested and is hungry of information as much. This means that person has to go through many documents of many branches of engineering, and that's interesting one. That is because one works on coordination, one has to coordination. You can do coordination only when you have either references of other documents which you extract and read them for purpose of understanding and implementation. It doesn't matter which branch of engineering I am or you are, because overlapping actions or interactions are to be understood itself. It's not simply that I say I'm civil engineer, I don't care if electrical engineer, mechanical engineer, likewise, or the other, whatever else. You cannot say that. After all, it is engineering that we deal with, and we were taught some portion of electrical engineering, some part of thermodynamics engineering when I was in my degree course and diploma even. So I had a opportunity. It doesn't mean that I was an electrical, I become an electrical engineer because I qualified that subject, or become mechanical engineer, qualified thermodynamics. It doesn't mean that. What I mean was that we have to be serious about whole system, whole activities, all works. We have to be very serious. That was purpose of that. Otherwise, there will be no purpose at all. We can't simply jump away from that. So my dear friends, I'm stressing on quality engineering and coordination engineering, which you have to understand, use it, and finding it difficult for people to coordinate properly because of lack of concentration, of lack of interest. Our engineers do not understand value of you can say quality product, or value of coordination. Coordination is not that easy as we think sometimes. Sometimes it appears to be so easy, too easy, and sometimes it appears to be very much difficult. In both situations, we have to stand to tolerate and to apply it, and that's very important part. We can say we can't simply just dump away and say, okay, we are doing this. Let me put off switch off battery first. We cannot simply put off switch. Now, working designs, we have to consider working designs, and the manufacturing, we have to understand. Working designs are those workable designs which are practically implemented. It applies to every branch of engineering, civil engineering, electrical engineering, mechanical engineering, IT, and all, whatever are linked to work. Working designs means schematic design is converted to working design. That is more detailed, more standardized, more explanatory, and usually call them working designs or shop designs or fabrication designs. Those indicate explanatory notes and explanatory details, and people, our workers, apply those details, and these are of course approved. Our schematic design is a kind of prime design, that is based on feed design, which is before, you can say, which is conceptual consideration of how we are going to do feed. This is called FEED, front end engineering design. Goes to practical, or you can say conceptual designs or objective designs, like schematic drawings in every branch of engineering, including civil. And then we have working designs, which are based on real material, what we are going to get, and real dimensions, and how work is going to be complied with requirements. And we can say that working designs or shop drawings, working drawings and shop drawings are produced along with method statement, which are briefly described or understood. And we can say we can work now with that material, with that information, and we have to coordinate all information available from whatever branch of engineering or discipline of engineering is involved. And then we can say, okay, this is this fits in like this. So that's called coordination engineering, and it's very important part of engineering, because in construction without coordination work can't be done. Same way, well, it may be electrical or mechanical or different one, because there's very accurate fields. Dimension wise, you can say mechanical world, or you may say HVAC world. Likewise in buildings and some other exact dimensions are more important. In civil there will be some tolerances, but in structure we can't tolerate structural engineering, or you can say RCC buildings or structural steel tolerance is not much and it's not acceptable. So this means we have to consider all this point very frequently and very efficiently, and we have then to think of how to fix real quality in our country. Come what may, we have no excuses. We can't give any excuse on that. Quality is a requirement and requirement is a mandate. We have to apply it, we have to do it. There is no way we can say, no, give me concession this time, next time I will let you know. That's not acceptable, because engineering is based on facts and not on fictions. This is difference. Engineering is factual. It is real. And then this is delivered, and that delivered product performs. And if it doesn't perform that project, it's no product, it's scrap. We say work quality can't be compromised. No way, we can't even think of that. Why to compromise when money is spent, time is spent, and we can apply quality? Why to compromise with that? That's what is difficult. And we don't depend on fragile system only. Maybe it is good system, sound system, but product should speak. That's what we can say when product speak. This is speaking system, speaking quality system or real quality system. Quality system may fail, but product must be delivered qualitatively, and if that is possible, that's the best way, because we can't rely only on system, because systems we prepare that system. Maybe I'm not experienced that much, or we don't have that problem exposure, we don't have that and we have so many stoppages on way, so many, you can say, checkpoints on that, and that we can say there's so many existing red lines to be resolved, and we have to resolve them. And can we bring working environment to equality and coordination requirement? And how to do that means we have red lines that must be turned green, and many other countries working around. We have to be better than that, but unfortunately we are worst. And I'm blaming everyone on this, because we don't have any, I can say, mindset to be very strongly committed to quality. And that is our weakness. While other countries are doing that, we can't do that. We take it for granted, or we think, oh, no, doesn't matter. No system, no method, no quality follow-up, no individual development. Just they go on, and particularly in construction field, it happens so vaguely. Really, it's sometimes ridiculous of why we are working at all. We have to understand coordination. We have to work on required coordination during activities to achieve defined or expected quality profile on works. If we can't do that, why we should not revisit whole system? Why we should not revisit quality requirements and specifications that are needed or that are essential, and update our knowledge and called world working standards? Why do we apply work relational coordination requirement? And it's a must we have to think of. It's a reliable solution. We have certainly worsening state of quality system. We have certainly worsening state of quality of work, on how to improve such mandated works quality to certain minimum required marks, and that's important. We have to force ourselves to work on coordination and quality. And coordination is a requirement before quality, because you have to understand what is required, and it's our duty as professional, as engineer, that we should know what we are doing. We can't do blindly. Oh, we did last time and this time we do. That's not accept. Maybe you did a mistake last time, and why do you want to do that mistake? That question comes in, and there may be other problems which you have to solve. And we have certainly worsening state, as I say, quality of works and how to improve that is a question mark. We have not only to do that at our level, but that should be acceptable at world level or international level. We have to force ourselves that's requirement. And of course concrete, which is very important material, as we know, very expensive material but long running material. If concrete is done per requirement, per quality, it may stay double time you think it should. Maybe possible. If it's well protected, it's well trivial, it's well, understood how to handle this concrete, it may have double life. That's as even if there's a carbonation environment or there is corrosive environment, we have many precautionary technical uh, concrete, we say, is a component in constructions which amounts to major percentage of cost of construction. It becomes incumbent on us to care about quality of such component, and that's very important part. We come back to this role again because I don't waste time on this. We have coordination issue. Coordination in engineering is very important for public as well as for engineers because it keeps everybody thinking about coordination. If you don't have complete information, there is no way coordination can be done, because coordination has no academic level. It's practical aspect, it's practical world of engineering where coordination is learned and it's taught. And that's the important point. Means we are a scientific country, or we should be a scientific country. Both are different situations, and we have been missing. We have been missing coordination, and we have missing good engineering, and that's what we have to think about. And if we can think, I think that's a better way. And there were so many questions I put in. Coordination engineering a must on every project we should ask ourselves. And project means what? It's all performance activities involved from pre-designs to final completion of complete construction. There may be some questions to be answered by engineering community regarding quality and coordination and respective involvement in its entirety. Can we ignore these domains? And that's the point we have to answer to ourselves. Can we ignore these two domains? Domains first is quality and domain second is coordination. Can we ignore them? And that's the point here. How many of us conduct work for quality and coordination engineering? Everybody may claim, but really prove it that you work accordingly. That's an important point. And how many of us conduct work for quality and coordination engineering? It's not right time to contemplate and deliberate on this subject. It's what we're doing, but I'm doing alone. No one is raising any questions so far. Nobody is raising any question. And can good industrial practice be achieved? Can good industrial practice be achieved without moving through quality and coordination domains? Can engineering design be reliably carried out without involving quantity and coordination? And where are we going to? There are some projects which I'll look later on. Now I open this file of concrete which you're waiting for. That file is really very important one, which I found the specification. I'll be in touch with that now to see what we did last time, and that's very important point for everything. And we'll go there to see what results. Last time we were somewhere here. It was acceptance inspection for reinforcement, and before that it was last time we did it was yes, we had taken this about this part of cement, I think is no, yes, acceptance inspection of concrete. That's what we said, inspection of concrete. And we did all this. Yes, we did all this, and we have now we discussed about commentary, and we discussed what is slum, what is something you say chloride ion content, we start with our mass of unit volume. We start with chlorine. We discuss it again, just a refreshing purpose we are doing it. Chloride ion concentration greatly affects this resistance to steel corrosion. If you have chloride ion concentration greatly affects the resistance to steel corrosion. In cases where a large number of chloride ions are highly likely to intrude into concrete, in case where sea sand is used, frequency of testing shall be increased. That's what it says. Means chloride iron concentration greatly affects that. Temperature now is how much? I don't know what its temperature is. I'm feeling a little cold. This is the temperatures I think is coming. It's now, it says 25 degrees. Indoors should be less than that. And I think that's what it is. 25 degrees. I'm feeling cold. Maybe 10 degrees inside maybe 20 degrees. So I feel, of course, I should keep my fan off. That will be better, I think, this way. And we have to be serious about this issue. So chloride ion concentration greatly affects resistance to steel corrosion. In cases where a large number of chloride ions are highly likely to intrude into concrete, as in cases where sea sand is used, the frequency of testing shall be increased. Chloride ion. Now, inspecting chloride ion concentration of water in fresh concrete is available now. Concrete requires to be homogeneous, everybody knows it. Homogeneous means of same texture or same composition all around in units, in whole volume. It says concrete requires to be homogeneous and sufficiently workable for transport, for placement and for compaction. Whether it be fresh concrete sufficiently workable or it's not, may be visually determined to some extent. An engineer to accept material shall visually verify state of concrete for whatever defects at time of unloading or placement at site. No concrete determined to be insufficiently workable should be placed. First of all, no concrete that is insufficiently workable should be placed in order to enhance reliability. In order to enhance reliability and precision of visual inspection, engineers with adequate knowledge and experience concerning concrete should conduct inspections. Visual inspections shall be conducted by professional engineers who are responsible. If questions are expected to arise during determination, producing and accepting parties should consult with each other. For estimating water content per unit volume of fresh concrete, such methods have been developed as heating and drying method, dryer method, microwave heating method, drying under reduced pressure method, air meter method and capacitive method. However, precision of measurement is limited. In testing, the water content per unit volume of fresh concrete should be inspected exclusively to remove concrete containing excessive volume of water. It says in testing, water content per unit volume of fresh concrete should be inspected exclusively to remove concrete containing excessive volume of water. Precision of testing and method of calibration vary from method to method. Inspections should therefore be conducted after prior mutual consultations between parties, engineer and contractor, you may say. In cases where condition of concrete production has been inspected, in cases where condition of concrete production has been inspected and quality of concrete material have been inspected for acceptance, concrete mix proportions may be verified based on printed records of measurements. Unit quantity of water shall in principle be obtained through calculation using measurements in respect batches and percentage of aggregate surface water. Unit quantity of water in principle shall be obtained through calculation using measurements in respective batches and percentage of aggregate surface water. Water cement ratio or water binder ratio is an important factor affecting strength and coefficient of carbonation velocity, coefficient of chloride ion diffusion, resistance to frost damage, resistance to chemical intrusion, and permeability coefficient, which determine durability of concrete. Inspecting water cement ratio is therefore important. Water cement ratio shall in principle be obtained by calculation using printed records of measurements for cement and unit quantity of water obtained from percentage of aggregate surface water and printed records of unit quantity of water. When accepting concrete from a ready-mix plant with no equipment for printing material measurements records, verification may be made by appropriate method through consultation with producing party. In case where highly reliable production facilities and production and quality management systems are in place, concrete strength may be inspected before concrete placement by verifying qualities of concrete materials and mix proportion. In cases where production facilities or production systems are not reliable or where conditions of concrete productions are unknown or concrete is not produced as specified, however, no concrete strength can be verified in mixed proportion inspection. In that case, verification shall be made by strength test after concrete placement. Shrinkage strain should be measured in accordance with whatever requirements. It should be verified. It should be verified that measurement does not exceed shrinkage strain of 1000 micrometer. Standard value is shrinkage where concrete is placed under dry conditions for 6 months after wet curing for 7 days. When applying ordinary ready-mix concrete with a proven track record to a structure, inspections by shrinkage tests may be eliminated. Even if slump and air content of base concrete before a fluidity agent is within allowable limit, slump and air content of fluidity fluid concrete may show considerable fraction for determined fluidity agent doses. Therefore, frequency of inspection shall be increased compared to case of ordinary concrete, and these tests performed to both of these base concrete and fluidity concrete. For slump of both of base concrete and fluidity concrete, Tests be performed at high frequency from prior to placing works to period, confirming stabilized qualities on manufacturing. After that, tests may be performed in every 50 cubic meter, and visual inspection shall be conducted for each agitator trucks to monitor properness of workability and fluidity concrete. It's indeed that, it's no doubt that concrete is judged not to be in conformity with requirements on results of acceptance test inspection must not be placed. Concrete, if concrete was already placed into structure, this inspection as of structural concrete must be performed. Acceptance inspection for reinforcement. We had engineer shall assume responsibility for verifying before construction that reinforcement delivered to site meets quality requirements specified in design. And we can say there are steel bars type, versus format, type, then item, testing method, and then we can say frequency period. All of these generally confirmation of test result by provided manufacturers are there, and items are steel bars for concrete reinforcement, confirmation of test results provided by manufacturer, and then it is re-rolled steel bars, same applies here. Also reinforcing bars not conforming to requirements, then confirmation of test results provided by manufacturer, and epoxy coated reinforcing bars, same way provided by manufacturer, but confirmation epoxy coated reinforcing bars and threaded rugged reinforcing bars with large diameter. And also here you can say pre-stressing wire and pre-stressing strands, pre-stressing bars and pre-stressing steel not conforming to requirements, and say rolled steel for general structures, confirmation by manufacturer, and also rolled steel for welded structures, then rolled steel for building structure, as well as steel for structure not conforming to requirements. Likewise, here what we say, it is only right and proper, it's only right and proper that reinforcement process required quality as specified for design of structure. Inspection to ensure quality of reinforcement should be performed on prior placing works in advance. Prior to contractor assume responsibility for conducting acceptance test. Owner shall verify results. Concrete shipment or reinforcement shipment is generally made to fields directly from factories in form of bundle with manufacturer's certified mill sheet where name or abbreviation of manufacturer, name and type of reinforcement and legibly identified. General inspection be performed by confirming that description and kind shall be adapted to prescribed reinforcement by visual observation, and material properties, shape, size and weight of reinforcement conform to specifications by examining on mill sheet from product company. In case outlooks of reinforcement examined and measured by measured diameter, be measured reinforcement bars and calipers. When reinforcements except for when reinforcements except for reinforcing bars are accepted, when reinforcements except for reinforcing bars are accepted, same method of reinforcing bars be appropriately taken approximately taken when epoxy coated reinforcing bars, galvanized reinforcing bars are accepted. It's important to confirm that coating or galvanizing parts have no defects. For other types of steel then reinforcing bars, inspections may be conducted as for reinforcing bars. Inspection of construction. Inspection of construction. Inspection of construction. No, engineer shall assume responsibility for inspection. We are saying engineer in place of owner because the engineer works on behalf of owner and engineer is responsible on behalf of owner. That's a different story, but here we say engineer as though we say owner. And owner is the owner of responsibility, you may say. Contractor manage quality in each construction phase. Contractor shall manage quality in each construction phase. Owner of a structure says shall assume responsibility for inspection, shall verify quality of complete structure. It's difficult in numerous cases, rarely. Construction therefore be inspected. Construction shall therefore be inspected because before concrete placement or during concrete construction as standard practice. Inspection for transportation should be carried out. What way? Let us see. Inspection for transportation. What does it say? It says item is equipment and workers required for transportation. That is also per construction plan, and we can think of by saying confirmation by visual observation because it is transportation, method of transportation, and we have to follow construction plan in every case. Quantity of transportation, again we say confirmation of quantity and shall be prescribed, and all these items regarding transportation, method of transportation, quantity, prior to placing work and during transport. Transportation time, confirmation of time of shipment and arrival on site. That is construction standards based on placing out. In inspection of pumping, it should be verified as a standard practice that maximum pumping load on pump during pumping is equal to or less than 80% of maximum theoretical pumping. Now, inspection of casting, that is equipment and workers required, method of placement and quantity of placement, same way. Confirmation by visual observation, confirmation by visual operation, shape and size, that is quantity of placement, confirmation of quantity from shape and size of placing zone, and all shall be done by according to construction plan and quantity. Inspection of curing should be carried out in accordance, and this should be same equipment and workers, equipment and labor, method of curing and period of curing. All we have to say, which says equipment and labor requirements observation, and again we say construction plan we should have ultimately this plan. In cases in inspection for transportation, placing or curing of concrete before construction shows non-compliance with required standards, appropriate measures such as improvements of equipment, worker arrangement, or improvements of construction method should be taken so that required objectives are achieved. In cases when concrete has already been placed, shall be determined whether concrete within structure meets required purpose, and appropriate countermeasures should be taken. In cases where it is required to determine adequacy of curing, timing of formwork removal, introduction of pre-stress, or load applicability at early stage, it's desirable that tests for strength are carried out using specimens cured under conditions as close as possible to site conditions. In case of cold weather, inspection should be carried out in accordance with requirements, timing of termination of curing of formwork removal and shoring of smell should be determined on basis of strength of specimen cured under conditions as close as possible to site conditions, on basis of strength estimated using records of temperature of the concrete. And now site inspection of cold weather concrete, it says circumferential temperature, concrete temperature, and concrete temperature curing. So we have to do all this according to standards, and we had to go to inspection of hot weather concrete. Inspection of hot weather concrete is circumferential temperature, concrete temperature, placing and transportation time. All these have been discussed, and we have gone through. Let's discuss circumferential temperature and concrete temperature. Placing is a measurement of temperature is only an answer. And that's prior to construction work. During construction, we can say concrete temperature placing. We have to see material construction and limits are provided by temperature. It's very important. Where to be the limits that's required here. Transporting time, confirmation of transporting time prior to construction work and during construction work. Time from start of mixing to completion of placing shall not exceed 1.5 hours, and within a limit of provided planning. Inspection of mass concrete should be carried out in accordance with this clause. That's mass concrete temperature and placing is very important. It says measurement of temperature and frequency during construction work, and shall comply with the requirements of provided plan. Concrete temperature on curing and circumferential temperature under temperature control curing. In inspections of concrete transport and placement, types, models, capacities and quantities of transport and placement facilities, human resources assigned transport channels to site, methods of transport at site, and sections of concrete placement, locations of construction joints, and order and speed of placement shall be verified for compliance with construction plan. Was that if inspection of concrete transport and placement, type, models, capacities and quantities of transport and placement facilities, human resources assigned, transport channel to site, methods of transport at site, sections of concrete placement, locations of construction joints, and other order and speed of placement be verified for compliance with construction plan. It should be verified that pumping equipment has sufficient pumping capacity for concrete and pumping condition. Sufficiency of quantity, sufficiency of quantity of transportation and quantity of placement be controlled on period of transporting and placing respectively. Required volume for practical placing is generally about 2% larger than design volume as reasons of counting error of materials. Variation of density of aggregates, variation of air content, loss on unloading from agitator truck, bleeding after placing and deforming of form. Transporting time means period from start of mixing to completion of placing. Variation of temperature, variation of transporting time lead to change of workability. Variation of transportation time shall lead change of workability and other properties due to change of air content and loss of slump. If transportation time becomes extremely long, it will be difficult to construct in proper condition. Then transportation time means the period from start of mixing to completion of placing. Variation of transportation time lead to change of workability and other properties due to change of air content and loss of slump. If transporting time becomes extremely long, it would be difficult to construct in proper condition. Transporting time must not be larger than specified. In inspection of curing equipment, labor or workers' arrangement for curing and curing method shall confirm that moist curing temperature, controlled curing and protection from harmful effects would be executed according to description of construction planning documents. Curing period in days or hours is specified on section. Alright, materials and construction standard for most in inspection of curing equipment, the workers' arrangement for curing and curing method, it shall confirm that moist curing, temperature controlled curing and protection from harmful effects would be executed according to description of construction planning documents. Curing period in materials and construction standards for moist curing, temperature control curing and protection from harmful effects respectively. These specifications are determined from consideration for curing method, kind of structure, location, weather conditions, kind of cement, types used. For curing, inspection of curing period, execution of curing under prescribed condition would be confirmed. In cases where concrete is found to be unacceptable as a result of inspection of transport, placement and curing facilities and construction plan are considered unsatisfactory. Facilities should be improved and construction plan should be reviewed. In cases where structure has been completed, it should be verified. It should be verified that structure meets designated performance requirements. Inspection should be conducted during construction and improvement should be made immediately. Measures as preventive as possible should be taken. In order to estimate adequacy of curing, appropriate time for form removal and pre-stressing or to ensure safety of structure under working conditions, real concrete strength in structure must be estimated in some cases. For this purpose, concrete test specimen shall be cured under conditions as close to field conditions as possible. In cold weather concrete works above mentioned specification is extremely important. Materials and construction standards means daily temperature is 4 degrees Celsius. If mean daily temperature is 4 degrees Celsius or below, during construction practice, as cold weather concreting shall be required. Times of curing, termination, form removal and shoring dismantling shall be decided by using strength of specimen. Specimen cured under similar conditions to in place conditions. To in place concrete or using record of concrete temperature whose relationship between concrete temperature and compressive strength has been obtained. It is desirable that curing it is desirable that curing conditions for field curing a specimen are same as those for real concrete structure, but same temperature conditions cannot be realized by simply putting specimen at same time at same place as structure. It is recommended to measure temperature of field cured specimen and to investigate temperature difference between specimen and structure. So we have this equation. We also discusses this is integrated temperature is this del square percent. All this we have gone through this the problem now. Relationship between maturity M and concrete strength varies depending on several factors such as material used, mixed proportion and degree of drying or shrinkage, drying of moisture conditions. Now what to do? That relationship is confirmed by advanced tests. Concrete considered to as hot weather is prescribed. Considered as cold weather, mass concreting also there. We have principle of reliable thermal cracking, control in mass concrete. Principle of reliable thorough checking compared mass concrete is to evaluate temperature or thermal stress of structure in advance. However, in actual practice, due to complicated influence of many uncertain factors at construction stages, behavior of structure may often differ from prediction, no matter how detailed tests or advanced analysis are conducted at planning stage. In mass concreting, it is necessary to measure concrete temperature of structure continuously from time of placing to time when temperature of concrete becomes nearly equal to atmospheric temperature, and examine whether temperature changes kept within range predicted in advance. When measured temperature at each portion of concrete after placement largely differs from predicted value. When measured temperature at each portion of concrete after placement largely differs from predicted value, measures such as curing method and placing interval shall be re-examined and care be taken to Now we go to inspection of reinforcement. Inspection of fabrication and assembly of reinforcement we have to discuss. When inspection results reveal that fabrication and assembly of reinforcement parts not in conformity with requirement, works for fabrication and assembly of reinforcement parts shall be modified. Formalities items, testing method or inspection method, period you can see, and criteria for judgment. Item is kinds, diameter and quantity of reinforcing bars. Kinds, diameter and quantity of reinforcing bars. Other is prepared dimension of reinforcing bars. Kinds, placement and quantity of spacers and fixing method of arrangements of bars. And these are all, you can say, kinds, diameter and quantity, confirmation of test results, and by visual observation, method of measurement. Then measurement by scale is prepared diameter and confirmation of visual observation. And here is completion of curing and bending, that is cutting and bending, specifying diameter, and all should conform to designs prescribed visual limits. Or you can say, as we said, 4 spaces per square meter, like this we said, and this is what we have to think about all this. And arrangement of assembled reinforcing bars, that is arrangement and length of joint and anchorage, concrete cover. We have to conform the requirements of design and more than designed cover according to verification of durability. Then effective depth, we know allowable error plus minus 3% design dimensions. Spacing between center of reinforcing bars, errors plus minus 20 mm. After completion of bar placing and before placement of concrete, number and size of bars should be inspected. number or size of bars should be inspected together with location of bends, location of length of joints, spacing, accuracy in design documents, allowable error of criteria for judgment shall be decided under consideration with kind and importance of structure. Prescribed allowable errors for general concrete structure with columns, beams and walls are expressed. It is advisable to make as many inspections as possible during placing of reinforcing bars. Add errors a long interval from completion of bar placement to concrete placement. Inspection and cleaning of bars shall be undertaken to ensure that bar positions are correct and whatever mud oil or other material which have been deposited are removed. Concrete should therefore be placed quickly after cleaning and inspection at end of assembly of reinforcement. As allowable error of prepared dimension of reinforcing bars affects directly allowable error of location of assembled reinforcing bars, it shall be decided based on kinds and importance of structure, member sizes and directions. Allowable error for arrangement be assembled reinforcing bars shall be from 5 to 20 mm. However, least cover must be at least at every location containing joint parts. Relationship between concrete cover specified in drawings and specified in durability check shall be verified and decision criteria should be determined using following equation, that is cm greater than cd, measured concrete cover should be greater than specified one. This we had discussed now. Allowable error and prepared dimensions, we discussed this also. Allowable error and prepared dimensions of reinforcing bars, and that is struts, hoops, etc. plus minus 5 mm. Round bars 28 mm or below diameter, deformed bar 25 mm or below diameter, that's plus minus 15 mm. And round bars of 32 mm, dia or below diameters, below diameters, deformed bars 25 mm below rib plus minus 15 and 32 mm also 20 below plus minus 20 and more. So you can see total length after completion of cutting and bending plus minus 20. When inspection results were judged that preparation and assembly of reinforcing bars was not in conformity with requirement, it shall be modified properly. For bent reinforced bars, bending shall not be undertaken in principle due to the fact that it may harm quality of bars. Inspection of joint of reinforcing bars. Inspection of joint of reinforcing bars. When connecting reinforcing bars using gas welded joint, welding joints, mechanical joint as joint of reinforcing bars, strength of joint examined before using. Inspection of joint of reinforcing bars should be carried out in accordance with table. Inspections of joint reinforcing bars. There is table here, that is type, item, testing method, period number and criteria for assessment. Lap joint, which says assembly of reinforcement bars measured by scale and confirmation, complying with requirements of design. Same with gas pressure welding. Also we have gas pressure welding, that is location, outlook of expansion, inspection, supersonic flow, detecting test. Confirmation by visual observation and measurement by scale on all joints. Comply with design, method specialized in speed. You can see gas pressure welding, confirmation by visual observation, location, outlook, and measurement by scale and calipers on all joints. Complying with requirements of design document. We have here supersonic flow detecting tests. Methods, specified sampling, and we can say gas pressure welding. Complying with standard qualification, procedure, gas pressure welding technique published by Japan pressure welding. Guidelines of anchorage and we have butt arc welded joints, measurement, outlook inspection, detailed outlook inspection, measure by scale or confirmation, calipers and others. So we have all joints more than 5% here. Complying with requirement of design without surface defects, eccentricity, that is not more than 1/10 of bar diameter. Eccentricity not more than 1/10 of bar diameter. Slope of joint parts, not more than 1/10 of measured length. For details of guidelines of anchorage, joint of bars. Supersonic flow detective test method specified more than 20%, more than 30% samples, and follow guidelines. For anchorage and joint. Mechanical joint inspection test shall be executed on consideration with type of joint method. One inspection lot is assumed with pressure welding parts. That same working party constructed on same day, and standard of lot size about 200 samples. In case of manual gas pressure welding, all ST 490 bars shall be inspected, sampling inspections, and shall be conducted at 30 locations per inspection, lot for other types of parts. In case of automatic gas pressure, welding, sampling incomplete. We can say inspection tests will be executed on consideration of type of joint method. For details after this, one inspection lot is assumed to be pressure welding parts. That same working party constructed on same day in standard of slop size is 200 samples. In case of manual gas pressure welding, all 490 parts shall be inspected. Sampling inspection shall be conducted at 30 locations per inspection or other types of parts. In case of automatic gas pressure welding, sampling inspection shall be conducted at 10 locations per inspection. Inspections may be eliminated in case of heart punching method. When inspection results of paint for joints were judged not to satisfy requirement, appropriate measures shall be taken. Now what says? I says about, you can say, various joints have been developed for reinforcing bars to facilitate construction of joints. Inspections shall be conducted to verify that all joints for reinforcing bars meet designated performance requirements. Gas welding joints include manually give manually gas welded joints, automatically gas welded joints, and heart punching gas welded joints. Welded joints include butt arc welded joints, butt arc stud welded joints, butt resistance welded joints, and flare welded joints. Mechanical joints include crimped sleeves joint, crimped sleeve, threaded joints, threaded deformed bar joints, mortar grouted joints, friction welded, and other types of joints. Varies according to type of joint, material used, skill of engineer performing jointing, and method of jointing. And method of jointing. For details, you have to refer to guidelines. In general, inspection test for gas pressure welding is approximately executed. When judgment doesn't comply with the specifications, measures shall be performed according to recommendations by standard qualification. Inspections of form work and shoring. inspection of formwork and shoring should be carried out according to this table. Inspections of formwork and shoring. Item, testing method, period, frequency, judgment. Form material and shoring, all kinds. Material shape and size of form ties. Confirmation by visual inspection, visual observation, and prior to construction of form and shoring shall conform to sizes. Placement of shoring. Confirmation by visual inspection, observation, by scale. Completion of construction of shoring. Concrete members shall comply with specifications. That is placement of shoring. Position and quantity of form ties. Placement of shoring we have seen, position of quantity of form we have seen, and shape and size, position of form measured by scale, that is placement of planning. Great. We have here clear distances forms and enforcement places. Comply, we have to comply with that when inspection for form and shoring of some suspect results. When such results shall be taken. If structure is inspected upon completion, or inspecting formwork or supports may not be necessary. Defective formwork may, however, frequently cause problems. If a structure is inspected upon completion, inspecting formwork or support may not be necessary. Defective formwork may, however, frequently cause problems. During construction or after hardening of concrete, then formwork and support shall be inspected. Formwork and shoring must provide sufficient strength and safety against most unfavorable combination of actual loads prior to and during placing of concrete. Thus, inspections for those kinds of loads should be performed not to cause such unusual matters as expansion of forms, leakage of mortar, sliding, leaning, settlement, looseness of connection, etc. and you can say the inspections for those kinds of loads should be performed not to cause such unusual matters as expansion of forms, leakage of mortar, sliding, leaning, settlement, looseness of connections, and in configuration dimensions of structure or members, and safety of construction must be ensured. Additionally, construction accuracy of formwork and shoring shall guarantee construction accuracy of formwork and shall Construction accuracy of formwork and shoring shall guarantee required position, shape and dimension of structures, even if individual errors may be generally acceptable. Cumulative effects of these errors may have an adverse effect on structures. It must ensure that cumulative error does not come under. We have construction accuracy of formwork and shoring shall guarantee correct position, shape and dimension of structure. Even if individual errors may generally be acceptable, cumulative effects of those errors. Then, inspection of concrete structures that we have to go through here. Very important part. Important inspection of concrete structures. Engineers shall inspect surface condition and location, and dimensions of members. Concrete cover shall be inspected by known test we discuss, and slabs are likely to have inadequate concrete cover in members that are highly likely to be subjected to chloride attacks, and doubtful whether structural performance requirements are achieved because of trouble during construction, and cases where structure is found to be unacceptable or where detailed inspections become necessary based on results of inspections, including non-destructive testing. So, in case where it is doubtful whether structure performance requirements are achieved because of trouble during construction, structure performance shall be inspected as required. In cases where structure is found to be unacceptable or where detailed inspections become necessary based on results of inspections, including non-destructive tests, safety and serviceability of structures shall be verified. Concrete structure should be constructed as initially planned as possible within allowable range if these are to meet designated performance requirements. An engineer who accepts it should assume responsibility for conducting inspections for verifying whether surface condition is satisfactory or not, and whether location, shape and dimensions of structure are within allowable range or not. Concrete structures like pile foundations constructed underground and high bridge piers, for which no inspections are possible after removal of concrete, can be inspected only during construction. For structures constructed under several conditions, items for detailed inspections should be specified considering measurement, considering subsequent maintenance, and not only appearance should be inspected but also visual observation or measurement of dimensions, but also non-destructive testing should be conducted for inspecting quality of concrete. In order for structure to meet performance requirements, concrete cover as designed should be made available. For slab in which concrete cover is likely to be insufficient, or for members that are expected to cause damage to third parties, or members that are likely to be subject to steel corrosion due to chloride attack or carbonation, then non-destructive testing should be conducted. Expected during construction include frost damage to concrete of structure, poor concrete strength as determined based on results of concrete acceptance tests, and suspicion of structural safety for some well-founded reasons. In those cases, inspection should be conducted to verify designed designated performance elements requirements are achieved. Inspection of surface texture. We are reaching our goal where this refreshing is still, and refreshing is very important part of life. We know without refreshing it doesn't work. It doesn't work without refreshing, and refreshing is a very important part. We know we do something, we know something, and that's what we say. Start fun. And so inspection of surface texture. Inspection of surface texture means inspection of surface texture should be carried out, and that is situation of exposed concrete surface. Confirmation by visual observation. It shall be flat, shall not be recognizable defects like honeycomb, ridges, where bubbles, and shall not show insufficient cover. And measurement by scalers of cover, crack, measurement scale shall be within permissible limit to satisfy requirement. And conjoint confirmation by visual observation, measurement shall ensure mutually tight between lower and upper layers. And defects are recognized during inspection, countermeasures shall be taken. Defects on concrete structure surface shall, such as abrupt bulges and ridges, shall be removed to flatten surface, like bulges and ridges. Other surface imperfections such as honeycombs and fractured portions shall be removed and repaired. Initial cracks larger than allowed occur shall be repaired properly. In case of mass concrete, besides inspection carried out as stipulated, inspection of thermal crack shall be conducted by visual observation and form of removal. Timing of inspection of thermal crack shall be decided taking into account temperature change in structure. When inspection points out harmful cracks, adequate countermeasures shall be taken. When repair is necessary, appropriate measures, materials, methods shall be selected so as to satisfy requirements of structure. So we are going to go for a couple of minutes. Let's say if we can have something on this based on our connections. A couple of minutes at the back. So let us continue. I left somewhere here, and we said that it is about inspection of surface texture. Inspection of surface texture shall be performed prior to undertaking of measures such as repair of refinishing. We have to either repair or refinish. It is important, it is important to inspect surface just after removal of formwork and curing. It is very important. Visual inspection for surface defects such as cold joints, honeycomb, ridges, abrupt bulges, bubbles and different tones of colors shall be conducted by visual observation. Also, location where reinforcing bars have been visibly exposed or where shapes of reinforcing bars are clearly recognized due to insufficient concrete cover even before reinforcing bars have not been exposed. Prior to repair, examination of on-service environment, location and status of defect shall be performed. Repair should be applied while implementing adequate quality system programs so as to eliminate need for repair in maintenance phase. Initial cracks, yes, the thermal stresses due to heating of concrete, drying shrinkage. Although some cracks have little influence on structure, types of cracks may have hazardous to structures than others. Therefore, criteria of judgment shall be prescribed. Allow cracks with crack peaks be determined. And likewise, we have to see all these concrete to be regulated regardless of mass concrete soft lined herein. Then you can say joints between placed layers of uniformity of existing concrete and newly placing concrete shall be inspected. Everything has been inspected when the repose of the shutters. And when performance of joint between both concrete is considered insufficient from results, it should be repaired. Mass concrete investigation with special caution shall be conducted in addition to ordinary inspection of general structures due to possible development of thermal cracking, which may impair required quality or function of structures. Period of inspection for thermal cracking shall be decided in connection with alteration of temperature in structure, such as after removal of forms. When temperature of concrete becomes nearly equal to that of atmosphere, and when average temperature of member becomes lowest during winter. Metals used for crack repairs and their applications methods are very diverse. Filling, grout injection and surface treatment with resins are generally adopted. Epoxy resins are frequently used for repairing cracks. Physical properties, applicable temperature, usable life, cohesion and use condition vary even for one and same type of resin. Developments have been made both in materials and methods. Decisions should be made based on latest data. For a structure functions properly only by cutting water leakage. Cutting off water may replace repair. Inspections of location and dimension of concrete members, and that is, plane position plus minus is 30 mm, allow error 30 mm, and height in designs 50 mm. When we already discussed this. Inspection of location, shape and dimension of concrete members shall be in conformity with prescribed accuracy. Allowable errors shall be decided accordingly, considering types and importance of structures, and inspection of concrete board properties in structures. Inspection of concrete in structure shall be carried out in case of concrete which is unacceptable during acceptance inspection. Inspection during construction when these inspections are not properly carried out. Tests on specimen taken of delivery and subject to same conditions as structures. Tests on specimens taken from structures and non-destructive tests will be applied on concrete and structures. In case inspection evokes suspicion of performance of structure, tests shall be conducted to comprehensively judge structural performance from various aspects, combining non-destructive tests, tests on drill, cores, or sawn beams, and loading tests on structures. Loading tests for comfort, safety, and serviceability, and structures shall be conducted in accordance with, in case structure does not conform with performance requirements, appropriate countermeasures shall be taken, including removal of defective concrete, replacing of concrete, and strengthening of structure. A simple and reliable test method for concrete and structures is to be established. Judging from field experience, required performance of concrete structure can be assured by carrying out an accepted inspection, inspection during concreting is specified, and ensuring conformity accordingly. Omission of inspection of concrete this is permitted provided that acceptance inspection of as delivered concrete and placement related inspection regarding transportation, deposition, curing is duly carried out. However, each achievement of required performance cannot be assured when concrete is unacceptable, has already been placed in structure, or when inspection of concrete work cannot be duly carried out. In such a case, concrete structure shall be inspected as required. Three methods generally practiced for confirming quality, and that is, concrete structures are generally designed based on compressive strength of concrete. Identifying concrete strength is therefore extremely important. Then you can say non-destructive tests such as skimmed hammer tests should be conducted for inspection. Additional criteria should be determined fully considering variations of test results. Decisions should be made comprehensively by integrating results of inspections. This is a requirement for confirmation of performance, and that is, the structure when inspection evokes suspicion about development of required performance of concrete structures, concrete damage due to freezing. In such a case, detailed quality tests should be conducted on concrete structure to examine if structure can achieve required purposes. Test methods include non-destructive tests, skimmed hammer tests, and ultrasonic testing, tests using concrete specimen, cores or beams cut from structure, and tests for surface air permeability, tests for estimating concrete mix proportions, and loading tests. Qualities of concrete in structure may not be accurately judged by a single test method. Multiple tests should be combined to make a comprehensive judgment. When test results indicate performance requirements of structure are not fulfilled, appropriate measures should be taken, including strengthening of structure. Inspection of cover for structures or members of which inspection of cover are found necessary after hardening of concrete. Availability of designated concrete cover should be verified by non-destructive testing. Concrete should be inspected. If concrete cover is found unacceptable, the results of the inspections comparison shall be made among such methods as chipping and reconstruction of concrete and application of protective measures. Though cover is investigated at time of inspection of fabricated reinforcement, cover can depend on degree of security or formwork. Concrete cover of a complete structure should be measured by such non-destructive testing methods as electromagnetic induction, electromagnetic wave reflection, and non-radiography for important structures members that are frequently likely to be subject to steel corrosion under severe conditions, and members that greatly affect wind. Criteria for estimating concrete cover by non-destructive tests may be same, and applying criteria precision of measuring equipment should also be considered. Precision should generally be approximately 5 mm. Measurement error due to precision of equipment is assumed to be risk in when sampling inspection are generally conducted. Cross-section should be specified for measurement at certain intervals along length of structure. each time cross-section varies. Measurement should be taken at one point at least in each element in measurement cross-section. Measurement should be made for a length of 1 meter or more. Structure which concrete cover is found insufficient as a result of sampling inspections. Detailed investigation should be done. Insufficient cover reduces performance of concrete. To prove steel reinforcement, this requirement was established to ensure performance. Loading tests of member and structure. The important point is an load. In case where structure is considered unacceptable, inspections conducted before completion of structure or a verification of structural performance is considered necessary because of well-founded suspicion about performance of a structure. Performance of structure should be verified in confirming safety and serviceability of structure or members by loading tests. Method of loading shall be determined in order to certainly examine required performance. Special care be taken when determining timing and methods of loading, magnitude of load, etc., so as not to exert harmful influence on structure of members. Shall be ensured that amount of deflection and strain during and after loading tests are not unusual in comparison with values estimated in original design. Appropriate countermeasures such as strengthening of structure of members shall be taken in case safety and serviceability of structure or members are probably insufficient. When confirmation by load test shall be performed, it be considered confirming tests for performance of elements such as members and loading tests of structure. In application of test results, special attention requires to focus on that fact that performance assessed in loading tests is generally limited to part of elastic behavior. Load tests are specified in this section shall be conducted by a responsible engineer who recognizes the need of tests to verify safety, serviceability or other parameters of structure in cases where concrete strength is considered to be poor based on result of concrete acceptance tests or concrete inspections. During construction or where there is well-founded suspicion about safety and serviceability of structure. During construction, testing period shall be determined so that loading test could be performed after sufficient concrete strength is attained, so that introduction of weak spots on structure due to early application of load can be avoided. In case new construction method or special material is adopted during construction of structures, load test method shall be required as prescribed in construction specifications. Behaviors applied to structure or on member or by loading tests, they are vary depending upon magnitude and type of load. It is important to select an appropriate method of testing so that it can be judged whether structure or members of structures have strength and performance prescribed in design or they don't have. Loading tests may generally be done by static load application, but rate of application and magnitude of load shall be selected so as not to create weak spots by an expensive load. To examine behavior of members and structures, measurement of deformation in whole structure, deflection of respective members and strain of respective parts is required. Position for monitoring and load method of those examinations shall be properly selected based on purpose of test, method of analysis and degree of importance of structure. In static loading test, it shall be required to take care not to affect by vibration impact or other dynamic moment. Measurement error that are largely affected by atmospheric temperature change during test shall be kept as small as possible, or an adjustment of errors Interest results shall be prepared in advance. Cracking that may exert error. Cracking that may exert harmful effects on strength and durability of structure. Notably larger residual deformations or other cracking that may exert harmful effect on strength and durability of structure. Notably larger residual gum deformations or other defects in structure must be carefully observed, not only during but also after test. In addition, propriety of test method shall be confirmed together with performance of structure. For confirmation of dynamic pressure properties of structure such as natural frequency, vibration, load, test should be performed. Records. Results of inspection of concrete structure shall be organized and stored. Inspection records if repair, renovation, or other corrective measures are taken based on results of inspection. Reasons prepared, locations and range of materials used shall also be recorded. Results of inspection conducted Results of inspection conducted before structure is put into service serve as initial values in inspections. In maintenance of structure, performance requirements for concrete structures in such terms as durability, safety, serviceability, and restorability. Restorability should be met throughout its design useful life. Inspection results for concrete structures are important data for identifying initial conditions of structure for maintenance, preparing inspection, investigation plans, and analyzing progress of alteration. Inspection results for concrete structures are important data for identifying initial conditions of structure for maintenance, preparing inspections, investigation plans, and analyzing progress of alterations, their causes. Inspection results shall therefore be kept with construction records received from contractor. These records should in principle be retained as long as maintenance is continued. When maintaining a structure, not only construction records received from contractor, but also results of crack investigations upon completion of structure, results of inspection of concrete cover, investigation results of at time of inspection concrete during construction, results of concrete strength tests based on rebound, results of inspection of completed part of structure, and results of inspections of initial defects and past repair shall, if width is within allowable range, be sometimes useful during maintenance. Minimum number of records should be stored. Identifiers of structures. Identifier should be a test structure in which such information is described as name of structure, load design and construction, organizations, date of commencement of construction, date of completion, and persons responsible for design, material supply, construction and construction controls. Specifying names of chief design engineer and persons responsible for construction and construction organization is explicitly defining the defined position of respective engineers and paying tribute to engineers engaged in construction work. Expected to contribute to improvement of durability of structure and also improvement to maintenance. Names of chief engineers, persons responsible for construction management is explicitly defined. Position of respective engineers and paying tribute to engineers engaged in construction work. Expected to contribute to improvement of durability of structure and it's also important to maintenance. Special concrete. Special concrete materials and construction. Special concrete covers standards concerning matters required for construction, producing or constructing concrete structures that involve special materials, functions, construction methods, construction environment, structural formats, and production methods. In order to enable concrete structures to meet designated requirements, it is sometimes necessary to use concrete that involves special materials, functions, construction methods, structural formats, and production methods, or to construct concrete under a special construction environment. Materials and construction. Special concrete presents standard concerning matters required for producing or constructing special concrete that uses special materials and provides special functions includes expensive cement concrete, lightweight aggregate concrete using continuous fiber reinforcing materials, short fiber reinforced concrete, and high strength concrete. Concrete that's constructed by a special method includes high fluidity concrete, shotcrete, and pre-packed concrete. Concrete that's constructed under a special environment includes underwater concrete and offshore concrete. So what do you say? Says that concrete that's constructed by special method includes high fluidity concrete, shotcrete, and pre-packed concrete. Concrete that's constructed under special environment includes underwater concrete and offshore concrete. Concrete that's of special structure, format, or is produced by special method includes pre-stressed concrete, steel concrete, composite structures, and industrial product. There may be cases where special concrete is actually constructed or applied under different conditions from those described. Then special concrete shall be constructed in accordance with materials and construction general or materials and construction standards. In cases where stipulations in materials and construction special concrete are inadequate or where applying stipulations is not necessary, appropriate. Then special concrete shall be constructed according to materials construction, general materials construction standards. In case where stipulations of materials construction, special concrete are inadequate in where applying stipulations is not necessarily appropriate. Special concrete should be constructed so as to be fit in for actual conditions. Fully considering stipulations of materials and construction, special concrete for a special period. Then we can say special materials. Special materials method and types of construction are not sufficiently stipulated in the specification. Following guidelines have to follow. Recommendations of design and construction of steel fiber reinforced concrete, then manual of design and construction of lightweight aggregate, recommended practice for concrete made by continuous mixer, recommendations for design and construction of structures by pre-stressed concrete, recommendations for design and construction of pre-stressed concrete, recommendation of design and construction of anti-washout and steel concrete sandwiches structures, practice for concrete containing air and high range water. Recommendations for construction of high fluidity concrete, then for expensive concrete, then for you can see using silica fume in concrete. For design and construction of concrete structures using continuous fiber reinforced materials. Recommendation for design and construction of composite structures. Construction of high fluidity concrete, design of pillars member using reinforced concrete strengthened with steel fiber. That is design of pillar member. Recommendations for concrete pumping and recommendations for concrete tunnel concrete. Design and construction of electrochemical protection against corrosion. And then design and construction of structure using self-compacting, high strength and durable concrete. Guidelines for design and construction of concrete using high strength fly ash as artificial aggregate. And present and problem concerning leaching of micro components from concrete. And then guidelines for design and construction of reinforced concrete using epoxidism coated reinforcing bars. Guidelines for design and construction of ultra high strength fiber reinforced concrete. For design and construction of surface protection methods, shotcrete tunnels, shotcrete slopes. Design for you can say high performance fiber, because guidelines for design and construction of high performance fiber reinforced cement composite materials. Constructing a special concrete discussed with materials for construction. Special concrete frequently requires professional skills. It's stipulated that special concrete should be constructed under guidance of professional engineers with adequate knowledge and experience concerning specific types of special concrete. Acceptance tests for special concrete discussed in materials and concrete shall be conducted either by contractor or owner according to type of concrete. When acceptance tests for special concrete are conducted by contractor, owners require to verify results of we have done, we can say, let's move further. Says that Acceptance tests for special concrete discussed in this shall be conducted either by contractor or owner. When acceptance tests for special concrete are conducted by contractor, owner, or engineer verifies results of inspection. Definition. Terms used in standard specific construction materials and construction special concrete are defined as follows. Expensive concrete, expensive admixture, chemical pre-stress, chemical pre-strain, shrinkage, compensating concrete, chemical pre-stressing concrete, shrinkage, compressed concrete, chemical pre-stressing concrete, and lightweight aggregate. Because that is a expensive concrete. A type of concrete to which an expensive admixture has been added as a mineral admixture. Expensive admixture in admixture that is mixed with cement and water to generate ettringite or calcium hydroxide. Ettringite or calcium hydroxide for causing concrete to expand. That's expensive concrete. Then chemical pre-stress, compressive stress that is applied to concrete when expansion of expensive concrete is restrained by such objects as reinforcing bars. Chemical pre-stress, chemical pre-strain, initial strain that is applied to the straining object when expansion of expensive concrete is restrained by such objects as reinforcing bars. Chemical pre-stress, compressive stress that is applied to concrete when expansion of expensive concrete is restrained by such objects as reinforcing bars. Shrinkage, compensation concrete. Expensive concrete with expansion capacity to offset or reduce tensile stress caused by drying shrinkage using chemical process pre-stress. Then chemical pre-stressing concrete. Chemical pre-stressing concrete, expensive concrete with expansion capacity sufficient to leave chemical pre-stress, even in case of drying shrinkage. Chemical shrinkage compensated concrete, and before that it was shrinkage compensation concrete, expensive concrete with expansion capacity to offset or reduce tensile stress caused by drying shrinkage using chemical pre-stress. The chemical pre-stressing concrete, expensive concrete with expansion capacity sufficient to leave chemical pre-stress even in case of drying shrinkage. Shrinkage compensated concrete, reinforced concrete to which chemical pre-stress is applied to offset or reduce tensile stress caused by drying shrinkage, mainly by using shrinkage compensation concrete and sustaining expansion of concrete with reinforcing bars or other materials. We'll take up this next time. This is a very long one. There's no way we can take it immediately, and we'll let this, you can say, this take. Now you go back to quality, concrete coordination. Also we see time left. We're going to this sheet here. Common support reliable coordination. We're going to quality and coordination a long way to understand, to discuss, and it's very, very interesting to see how can we understand that. Communication support, reliable coordination. Because it's a plant here, this is a view of ethylene plant. It's a kind of mega project with having all disciplines involved, all branches of engineering involved. You may say it's something unique. We have to consider such plans because it's got many, many foundations and different types of land reclamation at seashore, onshore projects. And quality talk we're making for such mega projects. Major vessels, stationary as well as reciprocating, major foundations, major equipment are all made available through such designs projects. That's a very important point we have to understand. It's no joke. No, it's no joke. Means whatever is to be done is to be done, and that's important. We'll be back on this next time, of course. We'll be back on this. Meanwhile, I'll take your leave for time being with my email. So today's program will close it from various points of views.